So for 6.4, we are working with relations and functions. We have to define those terms first before we can move on. But we're going to be representing them, we're going to be manipulating them a little bit, and evaluating. So first, what I need you to do is define a relation. A relation is a set of ordered pairs. So it's a group of coordinates all listed together. That's all it is. Okay, we are also going to be working with the domain and range. We have defined these before, but I want you to write them again. The domain are the x-coordinates in the ordered pairs, which means that the range are the y-coordinates. All right, last definition is the definition of a function. A function is a relation where the domain is paired with exactly one element of the range. Okay? To denote a function, instead of using y, which we've been using before, now we're going to be using f of x. F of x, the f tells us that it's a function. Inside the parentheses is what our variable is. Okay? So a function is when each item in the domain has only one thing that it's paired with in the range. So one domain gets one range. And we call it f of x now. So for example 1, we have several parts to example 1. For the first part A, we want to state the domain and range, and is it a function. So we have 1, 2, 3, 4 points listed here. After you guys are done writing them down, we're going to state what the domain is, we're going to state what the range is, and then we're going to use that to determine if it is a function. Okay, so if the domain, looking back at the definition of domain, is just the x-coordinates, my domain here would start with, what's the first x-coordinate? -4. So -4 is in there. What's another one? -3. Then the next one is? -2. And what's the last thing in the domain? +2. And we put those in curly brackets. The curly brackets mean that it's a list of items. Okay. So if my domain is just a list of the x values, what would be in my range? What would the first thing be?
5.
Yeah, +5, -4, 0. And then -4 shows up twice. We do not have to list it twice. So after we've written -4 once, you don't have to write it again. So we have 5, -4, and 0, and that is all we need to write. Okay, so the next question is this a function? Now, let's think about it. My definition of a function, each item in the domain has only one thing that it's paired with in the range. So let's look at this thing again. -4 was paired with 5, right? -4 and 5? -3 was paired with -4. -2 was paired with 0, and +2 was also paired with -4. Are any of these x's paired with more than one y? No. -4 has one, -3 has one, -2 has one, and +2 has one. So is this a function? Yes, it is.
That's all we have to do?
It does not matter that one of the y's shows up more than once. What we do not want is any of the x's to show up more than once. So we want no repeats in the domain. No repeats in domain. If we have a repeat in the range, it's okay. We just do not want any in the domain. Okay? So let's look at this represented in a different way, because some people understand more when we're looking at something pictorially or graphically. So I'm giving you two domains and ranges. I've already listed the domains and ranges for you. After you get it all written down, I'll tell you what pairs with what, and then you can tell me which one's a domain, or which one is a function and which one is not. Okay, guys, so in the domain for my first one, I have 1, 4, and 6. In my range, I have -9 and 3. I am telling you, we're going to pair 1 with -9. We're going to pair 4 with 3, and we're going to also pair 6 with 3. Is this a function?
Yes.
Yes, it is. Because each domain has only one element in the range. Okay, so each domain has only one thing in the range. Let's look at the second one. I'm pairing 7 with -3, 2 with +3. I'm also going to pair 2 with 6, and -4 with +8.
No.
Is that a function?
No.
Why?
There's not another x.
Yeah, because that 2 has how many y's?
2.
It has 2 y's. That's not allowed. So this is not a function. So we are still in example 1. We're going to look at several different equations now. And from just from the type of equation that it is, we're going to determine together if it is a function or not. So our first equation is y equals 10x plus 2. Do you guys know what kind of equation this is? What does the picture look like of this one?
Slope intercept.
It's in slope-intercept form, which means that it's a line. It's just a straight line. Okay? So it actually is a line that looks something like this. Is this a function? Does each x have only one y? I'm going to give you this point, and I'm going to tell you that that's the point x equals 1. It has a y value on the line. Does it have any other y values besides the one that's on the line? Do you see any other y values? Which way would I have to go to check for other y values? X goes side to side, y goes up and down. So if I'm looking up and down, are there any other y values besides this point that x is equal to? No. It's only this point right here. What about this point right here? Let's say that's x equals 5. There's a y value right here where it's touching. Are there any other y values? No. So is this a function?
Yes.
Yes. Lines are functions. Each x has only one y value. Okay, let's look at another equation. Y equals x plus 4 squared minus 9. What is this equation? What is the graph called? If it has a squared, what type of graph is it? Not a line. What other types of graph do we know? It's a parabola. Well, how many types of graphs have we talked about, guys? Lines and parabolas. Yeah, we'll get there. Okay, so this is a parabola. It looks something like this. Remember, parabolas are growing out at all times, so it's never going just straight up and down. So is this a function? Let's say this is x equals 0. If this is x equals 0, there's a y right where the point is. Are there any other y's at x equals 0? No. What about here? Let's say that's x equals 3. Are there any other y's going up or down at x equals 3? No. So is a parabola a function? Yes, it is. So let's look at this thing. X squared plus y squared equals 4. You're out. Okay, so we have not dealt with this type of graph before. Because I have an x squared and a y squared, this is actually a circle. So a circle, which looks like this, that's what the graph looks like. Is it a function?
No,
Why?
because it's not open.
Because it's not open?
And equal. Yeah.
Well, yeah.
There you go.
Let's say that x equals -1. So if this is x equals -1, is there another y value besides this one that I'm touching right now? Yeah, where is it? Straight above. So this one has how many y values for that point? 2. So no, it's not a function. Okay. Last one like this. Y equals the square root of 3x plus 1. Okay, because this is a square root, it's actually, the shape is half of a sideways parabola. So it's half of a sideways parabola. That's what the graph looks like. It actually looks something like this. So it's just half of it, and it's going sideways. Would this one be a function?
Yeah.
Yeah, let's say this is x equals 0. There's only one y point right there. What about here at x equals 2? Is there more than one y? No. What about here, let's say that's x equals 10. How many y's are for that one? Still just one. So is this one a function? Yes. So what way are we looking when we're looking to see if each x has only one y?
The graph is
We have to look at the graph, and we have to look that there's nothing touching above or below, right? That is called the vertical line test. So let's actually give it a name. The vertical line test, vertical is a line that goes up and down, is used to determine if the graph of a relation is a function. So how the vertical line test works is if the vertical line touches the graph, so if the vertical line touches the graph more than once, it is not a function. Okay. So if the vertical line touches the graph more than once, it is not a function. So what I actually do when I'm looking at these problems and trying to decide if something's a function or not, after I graph it, I literally take my pencil and I make it a vertical line and I slide it across the graph that I've drawn. If it's ever touching more than once, you can automatically say it's not a function. So you can use your pencil to slide it across to figure out if it is passes the vertical line test. You could also just imagine a vertical line passing through the entire graph. I actually need something to physically use in order to look at it. So that's what we're going to practice right now. So example 2, we're actually going to graph a couple things and determine if it is a function. So draw a set of axes and we're going to graph the equation y equals 2x plus 1. Okay, so let's see if you guys remember how to graph this. What is the y-intercept here? 1. What is the slope?
The 2.
2 over 1. So we go up 2 over 1. Up 2 over 1.
Function.
Okay, so let's graph it. Draw a straight line.
How do you try function?
So draw the line through those points. And what I want you guys to all do right now is take your pencil and do the vertical line test on it. So slide your pencil across the graph. At any point, does it ever touch more than once? No. So does it pass the test? Yes. So is it a function? You betcha.
So we don't have to put like function, not a function. Yes.
You can just write yes or no. Not bad, right?
That's easy. Is that how this whole homework is?
Look. A good job.
Alright. So you have to write the work right there?
We're going to practice with 2 more.
You still have like a little graphs in the back.
Part C, let's graph y equals, let's do x plus 2 squared plus 4. I will give you guys a hint to start out with. This is a parabola. It's in vertex form. So what's my vertex? So my vertex is -2, positive 1, 2, 3, 4. Remember, the a, or the number in front of the x squared, tells us if it is wide, narrow, or regular. There's nothing there, so it's a regular parabola opening which way, up or down? Up. So draw a parabola as best as you can, opening upwards. And will you guys do the vertical line test on it right now? So take your pencil or pen or whatever writing utensil you are using. Slide it through the parabola. If you do it correctly, does it ever touch more than once?
No.
No. So is it a function?
Yeah.
Yes. Okay guys, last graph. We are going to graph x squared plus y squared equals 16. We did a brief one like this. Do you guys remember what shape it is? Circle. This is a circle with a center of 0, 0. And a radius of 4. So you're actually going to go up 1, 2, 3, 4. Down 1, 2, 3, 4. Right 4. 1, 2, 3, 4. And left 1, 2, 3, 4.
Yeah, I got you there, man.
We're gonna, we're gonna learn it later. We haven't done it yet.
Figured it out.
Okay, so here's my circle with radius 4. Do the vertical line test on it right now. So if I'm passing my vertical line through, it touches, it's touching, it's touching, it's touching. Does it ever touch more than once?
Yeah.
Yeah, throughout the whole thing. So is it a function?
You know, like in Doctor, when you have to put those things up.
Okay, so now that we're done with the graph, I'm going to actually be giving you functions, and what you're going to have to do is determine or evaluate for a given value. Okay, so we're going to be working with 2 functions, f of x and g of x. Each of these are functions because it is given as f parentheses your variable and g parentheses your variable. The letter in front of the parentheses does not matter. Typically we start with f and then we go g, h, and so on. We call this one the f function because it uses an f in front of the variable. This one is called the g function because it uses a g in front of the variable. What is inside the parentheses is what your variable is. So inside the parentheses it's telling us that we are using a variable of x. So when I ask you to evaluate the function for negative 6, we read this as f of negative 6. So what do you think I'm going to do with that negative 6? Plug it in for x in the f function. So f of negative 6 is equal to 3 times negative 6 plus 5. So that's f of negative 6 equals negative 18 plus 5. So f of negative 6 is equal to negative 13. And that's your answer. After I've told you what to evaluate for x, make sure that in your function you are plugging in the negative 6 so that I know what it is that you're doing. This means that here's your x, so our answer could be represented as a coordinate with an x value of negative 6 and a y value of negative 13. So this is my x, here is my y. Make sense? Not too bad? So what happens when I put an expression inside? So part B, f of x plus 1. What am I going to plug in? X plus 1. You want to make sure you put it in parentheses. So f of x plus 1 gives me 3 times x plus 1 plus 5. So that's f of x plus 1 equals, what would I do on the right-hand side? Distribute. So that's 3x plus 3 plus 5. So f of x plus 1 is equal to 3x plus 8. Can I simplify any more? Nope. So that's your answer. Sometimes when you're plugging an expression in for x, your answer is just going to come out as another expression. So you simplify as much as you can, but then you're done. Okay, so what about part C? I have f of y. What am I going to plug in for x? Y. So what would expression come out to? 3y plus 5. Can I simplify that anymore? Nope, so that's your answer. So in this case, we just replaced x with y. That's all we did. So now we're working with the g function. Remember, g of x was equal to 2x squared minus 7. Okay, so now we're working with the g. So it's the same thing though. So what I want you guys to do right now is by yourselves do part D. So I want you to find g of negative 4 by yourselves right now. Okay, so really quick, just for the sake of time, we're going to plug in negative 4 for x. So this is going to give me 2 times negative 4 squared minus 7. And we do have to follow order of operations. So that means I have to do the exponents first. So that gives me 2 times 16 minus 7. 2 times 16 gives me 32 minus 7. So my answer, g of negative 4, comes out to 25. We're going to skip E, but I do want to do the next part. So we are looking for g of x plus 1. So you guys should be able to at least plug this in. What am I plugging in for x in the g function? X plus 1. So this is going to be g of x plus 1 equals, and remember when you're plugging that in, you want to make sure it's all the way in parentheses. So that's 2 times x plus 1 squared minus 7. Okay. Order of operations tells me I have to use parentheses first, which we have x plus 1, and then exponents. X plus 1 squared. How can I evaluate that?
X squared plus squared.
How'd you get that? you did FOIL, or you can also do box method. Remember, you cannot just distribute the exponent. That's not allowed. So I'm going to do just a quick box method. X plus 1 times x plus 1. That gives me x squared plus x plus 1. So this is 2 times x squared plus 2x plus 1 minus 7. Now what does it look like I need to do? So distribute the 2. So g of x plus 1 gives me 2x squared plus 4x plus 2 minus 7. So g of x plus 1 equals 2x squared plus 4x minus 5. I don't need you to factor it. I don't need you to pull out any GCFs. This is all I need, so you can stop there. Okay, f of 2 plus g of 3. Now I'm taking both functions. These are still the same ones that I gave you at the beginning, but I want to add them together. What do you think I need to do very first before I can do anything else? Do you know what f of 2 is? Could you figure it out? Okay, so let's find f of 2. Remember, the f function was 3x, so that's 3 times 2 plus 5. So we're using the same one that I gave you at the beginning of the example. So f of 2 is equal to 3 times 2, which is 6, plus 5. So f of 2 is equal to 11. How would I find g of 3? Plug it in. So that is 2 times 3 squared minus 7. So g of 3 is equal to 2 times 9 minus 7. So g of 3 equals 18 minus 7, which gives me also 11. So then I want to find f of 2 plus g of 3.
Why is it g of 3 again?
Because that's the problem that they give. F of 2 was 11, g of 3 was 11, so my answer comes out to 22. So you have to evaluate each one separately, and then we can add them together. H is the same thing, but subtraction. Part I is the same thing, but there are variables inside. So what you would do there is combine like terms, but then you would have to stop after you're done combining like terms. So very last thing I want to do is I want to be able to find the domain from the actual equation. Whenever the problem asks you to state the domain, what I want you to do is ask yourself, what can I plug in for x? That's what we want to ask ourselves. What can I plug in for x? To give me a real solution. Remember, we have no more imaginary numbers. Okay, so look at part A. I know it's a function. They're telling me it's a function. Our function is 10x plus 2. So we want to ask ourselves, what can I plug in for x? And that means, can I plug anything in for x, or am I restricted? And I want to get a real number as an answer. So this is a line, 10x plus 2. Am I restricted on what I can plug in for x? I can plug anything in for x and get a real number in this one, right? I could plug in 1 for x and get a real number. Could I plug in -5 for x and get a real number? Could I plug in 1,050 for x and get a real number? Yeah. So I have no restrictions. So my domain would be all real numbers. Okay, I have no restrictions. I can plug in any number I want and I would get a real number as my answer. Okay?
How you know that?
Now these last three, I am restricted a little bit. So look at part B. I have f of x equals the square root of x minus 1. How am I restricted with a square root? Can the inside of my square root be a positive number? Yeah. Could it be 0? Can you take the square root of 0? You can. Can it be a negative number? Not if we want only real answers. So I need to figure out what x makes that inside 0, and I can plug in anything bigger than 0. So with square roots, we set the whole inside equal to 0. So x minus 1 equals 0. Add 1 to both sides. So we get x equals 1. Now when I plug 1 in for x, that gives me 0. Can I plug in anything larger than 1? Like 2. 2 minus 1 gives me 1. Can I take the square root of 1? Yeah. So I can plug in anything larger than 1. Can I plug in anything smaller than 1? No, it'll give me negative numbers, right?
Yeah.
So my domain is any x greater than or equal to 1.
So, how'd you get x minus 1 equals to...
Okay, last thing, guys, fractions. X plus 2 over x minus 2. Thinking back, there are a couple things with fractions that were not allowed in the denominator. What is one thing that is not allowed in the denominator? An I. What's another thing? You can have a negative in the denominator. We can do 7 over, or we can do 4 over negative 2, right? But you can't have a square root. And then think all the way back to elementary school. What was not allowed in the denominator? The very first thing when we learned about fractions. You can have a smaller number. Somebody said it. 0. Let's think about it. If I give you 7 over 0, what does that answer come out to? 0 times what gives me 7? Nothing. So what's my answer? No solution or undefined. We cannot have 0 in the denominator. So looking at my fraction, I'm not limited to what I can plug in except for one number. What is the only number that I can't have equal to x?
2.
Well, if my denominator can't be 0, let's set the whole thing equal to 0. What makes that denominator 0? X equals 2. Could I plug in 1?
No, if you want to.
Yeah. Could I plug in 4? Yeah. Could I plug in negative 5?
No.
Yeah. Could I plug in 2? No. So my domain is all real numbers, but x cannot equal 2. So for fractions, we want to set the denominator equal to 0. Whatever we get as our answer, that's the only thing that we're not allowed to plug in. Everything else is fair game. You are allowed to have a negative inside the denominator. You're allowed to have a fraction inside the denominator. The only thing you're not allowed to have is a 0. So let's do part D first, or last, really quickly. We have 2x minus 8 in the denominator. So what would my domain be? We set it all equal to 0 and solve for x. So that gives me x equals 4.
Are we gonna have 8 of those ones?
So what could I plug into this thing?
Anything?
Anything. So all real numbers, as long as it's not 4. So I can plug in anything for x, as long as x does not equal 4.